Okay, so good evening. My name is Aaron Gelfand. I am a LabVIEW architect, as a lot of us here are. I have my own business called Gelfand Technology. I've been an independent for 7 years. Prior to that, I was an NI Alliance member. Prior to that, I was, like many of us, at NI. At a couple of these meetings, some people have said, you know, it's great seeing finished solutions. It's great seeing all these solving specific issues, but where do you actually start from? And so what I'm going to present tonight is getting there from here, a case study in architecting some small projects. So here's a scenario I found myself in last summer, just prior to one of the people in the forum saying, you know, I really want to see how people start and finish and come up with their architectures. This was literally a phone call I received. Hi, Aaron, can you give me an emailed T&M quote in 15 minutes for a project that uses 5 motors to transfer wafers between 2 different automates? An automate is a system that does wafer deposition. It does what's called epitaxy. We haven't locked down the rest of the hardware yet. Include travel time to come up to Dallas to look at the system, and we need the project done in 2 weeks if possible.
Cherry on top too?
What?
With a cherry on top too?
This is real? This is real. Now, this is the customer I have an ongoing business relationship with, and I am maintaining several different projects with them right now. And my first response was, you know, I just finally started this other project because it kept getting delayed, and you're wanting me to abandon that project and delay it again? And they're like, yeah. And so that project last summer finally got delivered about 2 months ago because of the interruptions that they kept saying had higher priority. And so that was how the call started. I asked a couple of questions, and we'll talk a little bit more about those. And I sent out a T&M not to exceed price quote in, I think it was 17 minutes. So I was able to say, I don't think it's going to cost more than this, including travel time, deployment. We were assuming that almost all of the debug would be done by them on site, because I actually do have some replicas of most of the hardware in my office. I have motors. They don't connect to anything, but I have the motors, so I can test communication with them. So it's, okay, where am I going to start? So what do I need to know generically? I need to know, how does the system work? I need to know, what are the I/O points on the system? In this case, we have a couple of valves that we're opening and closing, so I have some digitals. I have the motors that I'm going to be moving, and I actually need to know if the valve actually opened successfully or not, so I have a couple of digital inputs. I also need for safety, I want an e-stop. So I need a digital input for the e-stop. What is the system going to be running on? And the answer to that was, well, we have an old NI touch piece, one of their little touch modules. Let me FedEx it over to you. I got it and discovered we can't actually install LabVIEW on it, or at least not any current versions of LabVIEW. We can't update the Windows embedded image on it. So it's like, okay, what's the next PC we're going to run it on? So we had to switch PCs, and I had already sized it for my prototype for that screen by that point. And who's providing the hardware? You know, as an independent, sometimes the customers are buying the hardware and giving it to me. Sometimes I'm buying the hardware and having them pay me for it. And what are the lead times on the hardware? And because that affected which digital I/O products we needed. Not only, in this case, it wasn't only how many inputs, how many outputs, what the voltages are. It's what is the lead time showing on the NI website? And is it used in one of your other projects that you actually have one on hand for a system you're building? So what do I need to know more specifically? And if you're paying attention to the pictures, we now see that, hey, puppy's on board. How many motors? There were 5. But unlike all of the other projects I've done for them that use this series of motors that range from 1 to 15, we need two of them running in synchronization with each other, because it's going to be moving what they call the trolley that's so long that as you move over, you can have it over both of the motors or only over it will go over, so it's only being controlled by one motor. And so they have to stay in sync with each other. So we needed to figure out how many digital inputs there were for the valve position sensors, and they have, on the existing projects, they have different types of position sensors. And they have different types of outputs. Some of their systems, I have a digital signal for forcing the valve open. I have a different signal for forcing the valve closed. And on some of them, it's a single signal if it's either open or closed. So I need to know that in order to figure out what the hardware I'm using is. So we needed to know how many digital outputs, and the whole idea is to be able to move a product, move a wafer from one machine to another. And that actually isn't, that's an entire sequence of steps of opening the valve, moving the motor, moving an arm, moving the motor, closing the valve, moving another arm so that we can lift it, switch positions, and then the trolley can go all the way to the other side. So I need to know, what is the transfer sequence? What are we trying to accomplish? So how do I start preparing for this? Well, the first thing we have to ask is, how is the system going to work? What information needs to be displayed to the user? And I'll have some slides a little bit later on that the end user, in theory, needs a single button. Start transfer sequence, and abort transfer sequence just in case. In reality, I have more information because the technicians, the administrators, need more control of homing motors, figuring out the correct positions for everything. What are the common sense groupings within a system? Well, we have, in this case, I have valve readbacks to know that the valves are in the position I've told them to be. I have valve controls. I have the motors. So there's some basic groupings that are going to help inform my architecture. Also, what information needs to be stored? Do we need to store any information? On a system like this, who thinks we need information storage? I've got one in the back. A maybe. So the people saying yes, what do you think I need to store?
How much motor's been on, or how much motor's been on?
Okay. There can be usage logs. In this case, the customer didn't need that. But on all of my projects, I actually maintain error logs. What part of the system is generating errors? And I have new daily files, and we'll see some of the stuff I do with that.
How far back did you go? How far back did you store error logs?
So you'll actually see when I talk about reuse. So we need to pay outstanding technical debt. In this case, I have an existing relationship with this customer. We've used this motor on 3 different projects in different ways, but we actually, at this point, unfortunately, do have 3 copies of the motor code. So it's time to pay a little bit of debt, compare what bug fixes are in which versions, which features were added in which versions, and refactor it into a reuse library. Now, this isn't always relevant. You'll have some customers that you don't have these libraries available for, but you also have your own internal reuse libraries that you finish a project and say, hey, this reuse library worked great, but maybe I need to add this feature or this feature to make it work better. So we want to pay our debts. And then I can start with my design. I start my design, generally my preferred architecture is a parallel queued state machine. I do not use any of the off-the-shelf pre-built architectures, Actor Framework, D2MH, JKI state machine. Yes, I know, but at least I mentioned you. I know you're booing me.
It's okay. I don't want everyone using DQMH, so that's perfect.
So perfectly honestly, I'm more comfortable. There are a number of times where I've used other reference architectures and been bitten, and even though we know that Fabiola is fanatical about unit testing, I personally have been bitten too many times. And also, Actor Framework is good on very large-scale projects, but it has a lot of overhead and a lot of complexity for a quick, small, 2-week turn type project. But I start with reuse libraries. Some of the common reuse libraries I take from project to project are I have an error handling library that's been with me about 15 years now, that's continued growing and been refactored. I have a package of miscellaneous useful VIs. I have a file cleaner utility that automatically deletes files in specified folders with specified extensions after a certain amount of time. So I can say we're going to maintain data files for 30 days. We're going to maintain error logs for 15 days. I have a configuration engine, and I have a pathing library that's fairly common. And yes, this puppy is alive. It's about 15 minutes old in this picture, still nice and wet from coming out and having been cleaned up by Mama. So when I start in architecture, this is what more or less every project of mine over the last couple of years has started out as. I start off making sure my pane is at its origin, so if I was being a little bit careless and moved everything, it always resets itself. I don't have to worry about, oh crap, my stop button is off screen now. I also push my executable or LabVIEW VI version number into my front panel title. So if a customer is saying something is not working, I can always say, did you actually update, or are you running the same version that you told me about this problem that I've already fixed for you? And I see some head shaking there. I get my path to, in this case, it's my error logs folder, and we're calling time for food.
I think what we can do is we can continue to talk, and then maybe just we go like one row at a time.
Style schedule.
Yeah, like that deal. So people, if you are really hungry and you're about to pass out.
I just want a water.
Yeah.
I'm thirsty.
So does that sound good to everyone? That way, because otherwise we're going to take a break and then the presentation has to keep going, and then we're going to be here until 8:30. So.
Okay. So one row at a time. I'll keep talking. With my pathing library, it's designed that if it's the first time, I don't rely on installers getting all of my folders correctly. My pathing checks, does this product or this company folder exist? If not, create it. Does the error log subfolder exist? If not, create it.
So you use the hidden gem for checking if the directory is there, if not personally creating it?
I do not, because I first check if the company path exists, and I create that, and that's a sub-VI to my error logs, to my configuration files, etc. So it's effectively recursive, but only because I've built it that way.
So if anybody does not have something like this, just know that there's a VI that ships with LabVIEW that checks.
That will do a recursive create.
And if you install the hidden gem solid that Navigator so nicely put together for us, it installs it in there. So.
I think there are also one that is too.
Yeah, but the one in
Not efficient.
yeah, I think it's more efficient. It's more about the company.
You're making folders.
Yeah. So once I have my error log folder, I initialize my error handler. The error handler is a standalone loop. It's event-driven. It's only running when when errors are active and they actually age out of the system. So sometimes, if you've lost communication with something, it can come back. And so I actually have in my handling library, I filter errors based on how many seconds it is between I've received them, and that's based on both a unique name and the unique error code, as well as how I can specify how long it takes for them to actually clear out of my buffer. And so like here I have my default of just 2 seconds between errors, 60 seconds to clear. In some projects I'll make that variable exposed to the user. I initialize what I call my DVE. The DVE library for me is my data variable engine. It is a class-based configuration tool. And up here, I'm initializing my file cleaner. I'm giving it the error folder. I'm telling it if it has a TXT extension to kill it after 14 days. In this case, I have my file cleaner engine. as a parallel loop. I have my error handler as a parallel loop, and then I have my user interface event handler. So this is my baseline architecture for a lot of projects. At some point, I'm going to remember to save it as a VI template file. So then we get into defining the project-specific code. So configurations. Almost all software needs configuration. Hard coding values tends to bite you in the rear end. I'm sure we've all experienced that. So what needs configuration in this system? Well, serial ports, the digital lines, some of them might need to be inverted. Timing. How long does a valve take to open or close before, especially if I don't have a readback signal on it, because actually not all of the valves ended up with readback signals. Does it support simulation? Motors, we need to be able to program the speed, the acceleration, the deceleration. They also are going to each go to a programmed set of points, so we need some way of storing what is this physical location once the motor's been home and we've calibrated it. Digital I/O. In this case, we decided, because the customer had them available, we're going to go with an NI USB 6525, which has 8 digital inputs, 8 digital outputs. And because we've used them before on previous projects, I happen to know that, oops, there's a little caveat there that they have their output timing is actually their output is timing restricted. If you write at more frequent than 200 millisecond intervals, it will give you an error. And so, knowing that, it's something I have to take into account in the design. Fortunately, I knew about it in advance, so I was able to account for that. And so, in this case, what I did was I have my digital control loop that basically is state machine. And so, what I did was I did an initialize case, a read case, and normally we're just constantly enqueuing the read case. There's an error case that will clear out all of my references and try and restart itself, which I didn't put in the slide. And there's a write case. And in the write case, I maintain a timer. How long has it been since I last wrote to the output? If it's been more than 200 milliseconds, go ahead and write immediately. If it hasn't, re-enqueue the state, wait X milliseconds and re-enqueue the state until I've hit that 200 milliseconds and can proceed. The motors. Well, there were 5 of them, and 2 of them were supposed to be in sync with each other, and the other 3 are were asynchronous to each other and to the 2 of them. And the system design is such that, other than those 2 that have to stay in sync with each other, everything else is we only use one motor at a time. We move this motor, we do something, we move this other motor, we do something. And so in this case, I went with a single loop rather than 4 separate loops. The sync motors, the idea was we would use a shared digital enable line off the digital I/O to turn them both on, to start them moving and stop them moving at the same time, because, hey, the electrical signal, more or less speed of light, they should stay in sync with each other. And then what sort of commands do we need for the motors? Well, we need to do an e-stop on them. We need to be able to send the stop command to them, disable them. We need a jog so that they can start jogging, move to position command, and a home command. So, queued message state machine where I can send stop, jog, I tell it which motor we're jogging, move to position, which motor, which position, home, which motor. Then we define the UI. What does the user need to do on the system? Well, as I said, the end operator only needs to press a button that says start transfer. But configuring the system, calibrating the system require more information. So, but we also have to ask what should the user be allowed to do, what should the user not be allowed to do, and what can be done to make the user's life easier. So what you see in this picture is my configuration settings panel with a number of the items exposed, but you also see that the hard stop home buttons are all disabled and grayed out. Why should I be locking that off? Well, if you look in the lower left corner, my e-stop is enabled. So when the e-stop gets enabled, I lock off almost all of the buttons on the screen. User should not be able to do anything when it's e-stopped. Operator UI. So the typical end user has the one button that's transfer side 1 to side 2. We were eventually going to add a transfer side 2 to side 1. We'll talk about that a little bit later. And we have an abort transfer button. And the abort transfer button is disabled and grayed out because a transfer isn't in progress. Why allow the user to make mistakes? Why allow them to do things that aren't relevant? And so think about, what are you allowing a user to do? What are you not allowing a user to do to prevent them from causing damage to the system, or just putting the software in a funky state that you never envisioned it to be in? Charles?
That information, description, and tips of users and start hammering the button, why can they use it?
I have not done that, of saying disabled because of this reason. It's definitely an interesting thought for the future. So we also have operator and technician. And again, right now everything is grayed out, mostly because when I ran this, we were in e-stop mode because I didn't have anything wired up to my 6525. And so when we're jogging, I give the user the ability to say jog the x-axis motor, jog the y-axis motor, jog the slide motor, jog the trolley motor. Each of those motors can have anywhere from 0 to 0, well, a minimum of 2 positions, a maximum of 5 positions that they can go to. And so depending upon which axis is selected, I enable the jog, which is an external pendant that it's wired into the digital lines, and I will turn on the relevant buttons of copy count to X1, copy count to X2, copy count to X3, and X4. Not all of the motors have all the positions, so I only show the relevant positions. What does that copy button do for us? Well, if you look at some of the other code that I inherited when I took over this customer from a different company, they have a number of things where they jog the motor into position, and then they have to exit out of that where there's the screen that shows them the count on the motor, which might be a 9 or 10 or even 11-digit count. They have to write it down, go into 5 submenus below, and then type it in. Click! It's in the settings window. You can still go back to the settings window and type it in manually if you want, but poof, done. Nice and easy for the user. Although I know there's at least one person in the room that's sitting here going, you know, you really need to make your UIs more user-friendly. Been working with him for a decade and a half now. Much better user interfaces than I am, but I think I do halfway decently. We have the manual mode. In the manual mode, we have the buttons for the different motors that allow me to say, for my horizontal arm, which is one of my motors, go to position X0, X1, X2. For my vertical arm, I can do Y0, Y1. For my trolley and my slide, I can do 5 different positions. Well, some of the positions are only available if the valves are open or closed. And so if we do system 1, if on the far left corner, system 1 valve closed is actually closed, the X1 system button will gray out. The user cannot go to this because it's an illegal position. If they try and do it, they're going to ram the trolley right into the vent. Not going to really cause any damage, but they might drop the wafer off the tray, and then all of a sudden you're having to vent both systems, pump air in, and that 30-second mistake now is going to cost you 6 hours of downtime to recover from. So I try and figure out what is valid for a user, what should they not be doing, and prevent them from doing it. So then I have my admin and troubleshooting panels. I have an error table. So in this case, I ran this code with none of the motors hooked up, so I see the error that, hey, no response from the motor. We're not getting a response. If I hover over, we'll actually see it with no response from motor 1. It'll actually tell me specifically which of the motors isn't talking. And again, information also gets logged to file. And so when customer says, hey, we're seeing this bad behavior, one of my first questions is usually, please send me the error log file. One thing I want to do with my error handling library in the future is just put in an automatic emailer with their permission, so that it'll just send me the files automatically. Yeah.
DLC will do that.
Okay. And then I also, again, I have the reuse library. I can get the information to show me what's going on with all 5 motors at the same time. Are they homing? Are they jogging? Are they in motion? Are they in position? Are they ready? Are they faulted out for some reason? How much current are they drawing? You know, if they're steady, they should be drawing 100 milliamps, holding position, maybe 10 milliamps. If one of them is trying to hold position, carrying a lot of current, we know system's about to fail. Lower level software modules. So I have a higher level digital interface module. I have a higher level motor interface module. What data do I need to share in different places? In this case, I had a data structure for my digital input status. That really more or less only got thrown up to the user interface, but that also got in 2 ways. One is it gets thrown up right here. You know, I have my open and closed signals. Oh, sorry. Oh, I have those are my input signals, not the other ones are my output signals. But it also, as we said, it throws up to the UI what is allowed to be enabled or disabled at any given time. So I need some way of sharing that information at a low level with the relevant code. Likewise, the output status. The output status we write directly out and we put it on the front panel. We don't really share it anywhere else. And then and then the motor status. So once we're done with that, we start exercising the system and passing out the puppies. Unit tests, functional tests, and hopefully that finds everything prior to the customer testing. Unfortunately, sometimes we find ourselves having to refactor. What we discovered is, yeah, I have 5 motors sitting on my desk, I'm talking to all of them, and the 2 motors were turning on at the same time. And as far as I could tell on my system, I was always seeing them have the same count based on me toggling the digital line. If I started one of them and ran it for 50 seconds, they both ended at 1,563, for example. But once you put the trolley on it and both motors were loaded, they stayed in sync with each other. As soon as one trolley was loaded and one of the motors for the trolley was loaded and the other one was no longer connected, the 2 motors would get wildly out of sync, or at least out of sync enough that the gears, when you start moving the trolley into position that it's going to start touching the second motor, the gears don't mesh with the teeth anymore. So what we discovered after talking with the motor company is we needed a different set of motors. The ones we were using output a subset of the digital signals, and we needed ones that had more lines that output the quadrature encoder counts and input the quadrature encoder counts. So they ordered those. Fortunately, they were in stock. And, oh, hey, you know, I have a motor module in my code. I have specific case, in this case, it was case structures. It wasn't worth classing it out as the different motor types. But I could say, this case, changed, done, was able to get the code. They had the new motor shipped directly to me, gave me a wiring diagram, let me wire up the cable. I wired the cable up to go between the 2 motors. Tested, they always stayed in sync. I still didn't really have any hardware other than trying to do rubber bands to get a little bit of resistance, but they always stayed in sync, sent it to them, and they put the project on hold for 9 months. As far as I know, the system works. And I hit the delivery date. So this was the final architecture. We have the initialization. I'm loading up some of my variables, defining some of my variables. We have the file cleaner, the error handler at the top. I have my DAC engine, my sequencing engine, and my motor interface. And then, of course, there's completing the project. So, delivery to the customer, source code, installers, documentation, development version list. This is something I put in all of my documentation of going into Max, having it export the report of all of the versions of the drivers you have installed on your machine. So if someone has to recreate the development environment, they can. Reuse packages. So a lot of my libraries are compiled into VI packages. I just need to make sure, especially since a lot of them are internal reuse libraries, I remember to give them to the customer so if they go to go to someone else or start doing stuff in-house, they're not missing half of the code.
So you share them on a VIPC file?
I share them as a VIPM right now.
VIPC is a VIPM file.
Wait, a VIPC I thought is a combination of multiple VIPMs.
Yeah, so it's VIP.
VIP.
VIP. Okay, so you share just a bunch of VIPs.
Yes.
Just the VIPC makes it a lot easier to actually see all the versions in one single place.
Which is also a pro feature,
yeah.
And I've bounced back and forth a couple of times.
Yeah. The only thing on that one is, I mean, you're already providing a very professional release. That just makes one more thing to make it
a little bit easier, yes.
If they need access to source code.
What was that?
If they're probably not opening source code.
Yeah.
Yeah, but you never know. I'm a one-person shop. God forbid a bus hits me.
No, you win the lottery. Let's not. We're running over all of them.
Okay, so.
We win the lottery. We disappear. That's much better.
It would still help if you went on.
Well, it's not if you're in the middle of the night when we have a bunch of puppies, right?
So of course we have project completion, and then it's on to the next project. Has anybody actually seen X-rays of a pregnant dog before? It looks like something you would expect out of Alien. This is a skull, this is a skull, this is a skull, this is a skull. You see their little spines, and it actually only gives you a minimum count of puppies in mama, because the puppies can be blocking each other. So you usually know a minimum count, but it doesn't mean that's your final count. And so these little ones are 2 weeks and 1 day old right now, and will be available for adoption starting July 31st through Lucky Lab Rescue and Adoption. We ended up with 10 survivors. And for those of you who are local, sorry I'm leaving those of you on the phone out of this next one. So actually these puppies are available in Texas starting July 31st. They'll be available to the Northeast, New York, Massachusetts, Connecticut, New Hampshire, Vermont, etc. 5 weeks after that. We have to wait that long to give them more shots before they can safely travel. And for those of you who are local, Damien, earlier you were talking about laser sharks. I can't give you laser sharks, but it is that time of year that Alamo Drafthouse is doing Jaws on the water. They show the movie Jaws at Valente Beach Water Park, and your price of admission includes inner tube. You sit on the lake watching the movie, and we do have sharks in the water, of which I am one. So please, I'm always looking for more people to scare the heck out of. Any questions?
When you distribute your internal libraries, do you have those password protected, or you just open?
No, they're open. Nothing I'm doing in any of them is really, right now, all that IP specific or things that someone else can't build relatively easily.
Sure.
And the IP hasn't been an issue for me. Anyone else? Okay, thank you all for your time.
You get a